Welcome to doassignment-ca. Here's the problem. A falling body has an acceleration defined by a equals 9.81 times the quantity 1 minus v squared times 10 to the negative 4 in meters per second squared, where v is in meters per second and the positive direction is downward. The body is released from rest at a very high altitude. Determine Part A, the velocity when t equals 5 seconds, and Part B, the body's terminal, or maximum attainable, velocity as t approaches infinity. Now let's work through the solution step by step. Because acceleration equals dv over dt, we have a separable ODE. We move all v terms to the left and dt to the right, giving dv divided by the quantity 1 minus 10 to the negative 4 times v squared equals 9.81 dt. We factor the denominator as a difference of squares. 1 minus 10 to the negative 4v squared equals 1 minus 0.01 vefs times 1 plus 0.01 vef. Applying partial fractions splits the integrand into two simpler fractions, each with coefficient 1/2. Integrating the left side gives natural log terms. After simplification, we get 50 times the natural log of the quantity 1 plus 0.01 v over 1 minus 0.0 v equal to 9.81 t plus a constant c. Plugging in t equals 0 and v equals 0 gives the natural log of 1, which is 0, so the constant c is 0. Dividing both sides by 50 gives the natural log of the ratio equals 0.1962 times t. Exponentiating both sides and solving algebraically for v, we find v of t equals 100 times the quantity e to the 0.1962 t minus 1 divided by e to the 0.1962 t plus 1. This is exactly 100 times hyperbolic tangent of 0.09810 times t. For part A, we plug t equals 5 seconds into our formula. The argument of hyperbolic tangent is 0.09810 times 5, which is 0.4905. Computing that gives approximately 0.4547, so the velocity at 5 seconds is about 45.5 meters per second. For part B, the terminal velocity is found by taking the limit as t goes to infinity. Since hyperbolic tangent approaches 1, the terminal velocity is 100 meters per second. We verify this by setting acceleration equal to 0 in the original equation, which also gives v equals 100 meters per second. To summarize, the full velocity equation is 100 times hyperbolic tangent of 0.09810 t. At t equals 5 seconds, the velocity is approximately 45.5 meters per second. The terminal velocity, reached asymptotically as time goes to infinity, is exactly 100 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.